And we're up again. Hi, everyone.
Hi.
We're going to take a look now at using properties of exponents to simplify expressions.
This should be super quick.
Oh, I hope so. A little bit quicker than that last one. All right. So we're going to take a look at A, C, and then E. Don't worry, I'll slide down for you. We're not going to just try and fill that in. And then we're going to have you try B, D, and what comes after E?
F.
F. Oh, for fun, fart, and fish. Yay! Okay, so on the first one here, simplify each expression. We're keeping it real basic to start. So you have x to the negative second power. A note to self, unless you're writing it in scientific notation, you're like, what is that? Don't worry, we'll cover it in the next video.
You better know. I thought they did that in chemistry.
Oh, did
boy.
they?
Oh,
my
boy.
gosh. Did
well,
they
they're
really?
in chemistry. They should already, I don't know.
Yeah,
We'll
hopefully.
see. Whatever.
Maybe middle school. But rule of thumb, mathematically speaking, if it's not scientific notation, you have to get rid of the negative exponents for it to be simplified. Right, Fish?
Yep. It'll always say, make sure your exponent is positive.
Yeah, that's pretty much the rule of thumb. So here, the only thing we can do is get rid of the negative exponent. And negative exponents, like Fish talked about before in that properties video, you're going to take basically the reciprocal of whatever the base is. So whatever is being raised to that negative exponent, you're going to flip it. You're going to take the reciprocal. So this is going to go instead of, and I'll just put parentheses really to emphasize that there, instead of x over 1, that's going to be 1 over x. The quantity squared.
And make the exponent positive. As soon as you flip it, it changes the exponent to positive. And
then we can talk about using that power property. Technically, I don't really have to overcomplicate this, but 1 squared is just 1. So it actually just goes 1 over x squared. And that's it. That's simplified. Okay? Fish, you got the second one?
All right, so example C.
Ooh, this is weird.
This is a little bit scary because there's that parentheses. No, so what happens is a lot of students think they need to distribute.
Ooh, oh, why? Ooh.
I know. I don't know. They get fancy schmancy in the middle school.
Yeah.
You do not need to distribute. So the reason why is you do not have any plus or minus signs.
Plus or minus.
That sign in front of the 4 is a negative. Sorry, I smudged it.
No,
I thought they could see my fingers.
No, they can't. They can't.
Okay, I know. Okay, so you're not going to distribute to everything. You're just going to combine. And the reason why you can combine, there's no exponent outside of that parenthesis.
Ooh, good point.
So if you see that, there's no exponent. So just combine everything. So we're going to start with combining numbers. So 3 times negative 4, negative 12. Did that without a calculator.
I'm proud of you.
All right, so then z to the 7th. And z squared. The reason why you can combine these is because you have the same bases being multiplied. If you remember from the property before, same bases being multiplied, you're going to add your exponents. So 7, 8, 9.
Boom.
7 to the 9.
Oh.
Woo! Done.
Nailed it.
Now, be careful. A lot of students think they need to get rid of that negative sign.
No.
You only have to get rid of the negative sign if it's in an exponent. I don't know what people are thinking when they try to flip it. Why would you flip the negative 12?
Yeah.
Only if it's a negative exponent.
Yeah.
Done.
Negative 12 is just a negative number. Like,
I mean, I don't know.
Hashtag come on, people.
People get fancy.
Okay, I know. All right, let's look at E here. Oh, I don't want you to see that yet. Just kidding. Doesn't matter. Oh, this one's aggressive.
I'm going to have you do it.
You're
see if you actually know what's going on here.
What if I get it wrong?
I'll let you know. Don't you worry.
That would be embarrassing. Okay, so if I look inside the parentheses here, I got a Y. I wonder, what's the exponent on that? If it's not written, what's it understood to be?
I don't know. It's imaginary.
No, it's get serious. We're talking about that in chapter 5. How about it's a 1? That's understood to be a 1 on the Y for the exponent. So Y to the first, technically, Z to the third over Z to the fifth. Then you have the quantity cubed. Okay, now this is the great debate with mathematicians because there's multiple ways that you can approach this problem. You're like, are you serious, fun and fish? No, we're dead serious. You actually could simplify in the parentheses first, then work with the power property, okay? Or you could just apply that property and then simplify.
Let's do that way first.
Let's do that way first? Okay,
yeah.
I like so.
Now, there's no right or wrong.
Yeah.
It's just I'm the boss, so that's what we're going to do.
Yeah, we're making it happen. So we're distributing this power to each of the exponent, including the one in the denominator. That's all in a parenthesis.
Remember
Don't lose it.
That definition is you're going to distribute that to every single factor.
So 1 times 3, because technically power raised to power as well, if we think about that, is just going to be to the third then. Then you're going to have Z. I can make a Z, I swear. Oof, that's embarrassing. We'll leave it. 3 times 3 would be 9 over Z to the 3 times 5 would be 15. Okay, I got a lot of Z's on the bottom.
This is hard.
Oh, this is really hard.
I'm stressed.
So do you want to talk about negative exponents here? I say no. Right? I think that's
Not yet.
aggressive. Not yet.
Let's get rid of, so what we have to do next is we have another property.
Yeah.
And the reason why we know we have another property is because we have a z in the numerator and a z in the denominator.
Mhm.
So that is the quotient property, where if you have the same bases being divided, you can subtract your exponents.
Mhm.
So what's 9 minus 15?
That would be -6.
Okay, so put that in the top.
Okay, so I'll put
Z to the -6.
that. Okay.
Now, we have nothing left in the denominator. So whatever.
For
put a
right
1
now,
there.
for 1.
Perfect.
Yeah. So we're not done yet, though, right?
Now another property. We have a negative exponent. Now, if you remember, we said this in the first example. You never want to have a negative exponent with properties of exponents. So you're going to take the -6
Mhm.
that's in the numerator, and you're going to flip it.
Okay. Does the y stay, though?
It does. Does the y have a negative exponent?
Why are you
What
yelling
is
at me
that? Is
again?
that -3?
No, it's a positive
It's a
3.
positive.
Oh my
Leave it. Why would you move that?
I don't know.
And you're getting a text.
Why am I
Let's turn
getting a
this off.
text?
Oh
Who
my
is
gosh,
that?
inappropriate. You're like the kids.
I know, seriously. Take it away. Turn it in the dean's office.
I know, seriously.
So z, and it becomes what?
Positive.
Okay, so that's y to the 3rd, z to the 6th. Are you going to get mad at me if I go to do an aside with this?
No, that's fine.
Can I
Go
do
ahead.
that? Okay.
I'm
So
probably not even going to listen.
she probably will tune me out. Perfect. So it's just fun in us right now, guys. So I like to think of this when I have like the y to the 3rd clearly is going to stay, people. I like to think of this in terms of where do I have more z's at? Okay. I have 15 z's on the bottom. I have 9 z's on the top. So I clearly have more z's on the bottom. How many more z's do I have? 1, 2, 3, 4, 6 z's. If you think of this in terms of what I just stated, there's more z's in the bottom than the top. I'm thinking about it in expanded form, which we covered in the last video. Notice we come to the same conclusion. It's just that I use a slightly different property, a slightly different way of thinking about it. Are they both correct?
Yeah.
Yeah, we came to the same conclusion. But what gets frustrating when you get to these more complicated problems is that there is not just one way to do it. There's multiple paths to get to the end. So we encourage you, oh my gosh, what are you doing? On B, D, and F to take a look and to try these in several different ways. You should get to the same end as what we did on our answer key online, okay? All right.
That was one of your best side notes
Do
you've
you
ever
like
had.
that? Oh, I'm so glad you were proud of me. Okay, so I think we're done here. We're
Yep,
done with this one.
done.
One more video to check out after. Stay tuned.
Then it's time to go grocery shopping.
Woo! Trader Joe's friends, loving it.